Okay, my friends, so let's dive into this right here where we've got a whole lot of information kind of crammed into a histogram over here, but I don't, I'm going to ignore that histogram and focus more on this table that's over here because this has got a lot more demographic information. We've got broken down by political party, which I'm going to ignore for now. We're going to focus on this age bit and maybe the years in Ben, but definitely the age bit right here. So let's start with the question, with this question right here. What's the chance that someone wants Bend to maintain its small town character, assuming that they're 18 to 39? So that right there is how that would read using the language of conditional probability. Saying that out loud, I'm going to say it again. What's the chance, what's the probability that a respondent wants Bend to maintain its small town character, assuming that they are aged 18 through 39. So the first thing you have to do is focus on this 18 to 39 part. That tells us we're only looking at these people right here. Why focus on that? Because that is what given age 18 to 39 means. It means that's what we know happened. It's that sample space reduction that I mentioned. So assuming they're 18 through 39, so how many of those we got? Looks like we have 95 of them. Of those 95, what's the chance they want Bend to maintain the small town character? So what you're going to do is you're going to look, well, how many of those 95 said small town character? Looks like 33. So the probability, I'm going to use Google as a calculator. What is 33 divided by 95? That is about 35%. So the chance that someone wants Bend to maintain its small town character, assuming that they're aged 18 to 39, is about 35%. Now, let's compare that with what's the chance a respondent wants Bend to grow into a medium-sized city, given that their age is 18 through 39. So once again, we're looking at the 18 through 39-year-olds. Well, we could do the same analysis we just did, or we can realize that since we're looking at the same 95 people right here, if 35% of them said they wanted to keep it small town, that means the other 65% have to be wanting to make it be mid-sized. There's only two options, right? Either they voted to keep it small town or they voted to make it mid-sized. So if 35% of those 95 said small town, the other 65 are going to say a mid-sized town. Now, let's look at the other end of the age bracket as indicated by this chart right here and just go straight to the 65 pluses. And I'm not even sure why they chose these age brackets anyway, but whatever, they did. So let's repeat the same questions, but let's change them to what's the chance a respondent wants Ben to maintain its small town character, assuming that they're age 65 plus. So if we look at this, it looks like there are 97 respondents in this case in the age 65 plus category. Of those 97, 61 want it to stay the small town. So that's 61 divided by 97. That gives us a probability of 63%. That means the other 37% must want it to go and become a mid-sized town. So knowing those four percentages, go ahead and attack the next couple questions.